Hi everyone, my name is Navikumar son of Kumaran and my ID matrix is B112410413. Today I am going to explain about the question 1 which we have done for our assignment electronic principle. The question 1 is about operational amplifier as shown in my screen and the figure 1 is shown about summing amplifier circuit. For find out the final value, we have to use two equations which I have written in my screen, which is IRF and Vout. To find out the Vout, we have to calculate each voltage by its own resistor value. As shown in my screen, this is the final value. For the first one, V1 over R1, V2 over R2, V3 over R3, and V4 over R4. For each value, we can find out the current value. To find the total current for this circuit, we have to sum up all the current value as shown in my screen. So the final value will be 0.3572 milliampere. To find out the voltage output, we have to use the formula which is negative RF times by I total. So the final value will be negative 35.72 volt. So that's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Syamil Muaz bin Syamrizal. My matric number is B11241068. So today I will do a simulation for question 1. So first thing first, the component that I use is amplifier that got pin. So I put the supply negative 50 volt on pin 5 and then negative 50 volt for pin 4. So and then I put ground on pin 3. The others component I just follow on question. So the question asks to measure the IRF. So first thing first, the multimeter. First multimeter I put positive probe on here, here, and then negative probe I put after resistor. And then to measure V out, I put the positive probe on pin 6 and then the negative probe on ground, which is V in for 6 volt. So we run the simulation. So I got this 357.122 microampere for current IRF, and then for V out I get negative 3.57 volt. So that's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Anwar. Today I want to explain to you equation 2, which is to determine whether the red LED and green LED is on or off when we put VI is 0.5 and 1.5 volt. For the component in this circuit, we use the OM, which is LM741. For the resistor, we got 2K and 417 ohm. And the LED, we got the red and green LED. For the power supply, we got the positive and negative 50, 2 volt and ground. For the measurement tool, we got the multimeter and probe. Let's go see the circuit. This is how to construct the circuit, which is following by the equation. Let's go find the result when we put the VI is 0.5 volt. Okay, this is result when we put the 0.5 volt. For the V out, we got the negative 30.7, and the LED, we got the red LED is become on, and green LED is become off. For the result, when we put the VI is 1.5, okay, this the result when we put the 1.5. For the V out, we got the 15 output is 50 volt, and the LED, the red LED is become off, and the green LED is become on. Okay, that's all for me to explain to you the question 2. I pass to my partner Ali Zulkifli to explain the theory quality secret. Thank you.
Assalamualaikum. My name is Alif bin Zulkifli and I will explain about the theory and how does the circuit works. This is a comparator circuit using an op-amp to compare two voltage and lights up LEDs based on the result. The non-inverting input, which is the positive one, is set to a fixed 2 volt using a voltage divider. The inverting input, which is the negative one, receives the variable input voltage VI through its own resistor divider. When VI is greater than 2 volt, the op-amp output goes high to positive 15 volt, turning on the green LED. When it is less than 2 volt, the output drop to negative 15 volt, turning on the red LED instead. The two LEDs are connected in opposite direction at the output, each with a 470 ohm resistor. So only one LED lights up at a time, clearly showing whether the input voltage is above or below the 2 volt reference. This setup gives us a fast visual way to see how a comparator responds to changing input voltage. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muzammil Shihab bin Muhammad Anwar. Number matrix B1124104227. I am from Pillar R, Section 12. Today I would like to explain about the question 3 based on multiple stage operational amplifier op-amp shown in figure 3. So, we go through on the question. So, name the type of the amplifier of circuit A1, A2, and A3. So, as you can see in the screen, the type of the amplifier A1 inverting amplifier, and also A2 inverting amplifier. You can see the connection, okay, in the figure. So we can say input for the inverting terminal, non-inverting terminal ground. So this is the connection. You can see at here for A1, A2. And A3 differential amplifier, which means amplifiers the difference between two input voltage. Okay, you can see in the figure 3. Okay, alright. So this is the connection of the wiring. Okay, in the figure 3. So next we move on, calculate the output voltage of the amplifiers. So at here we need to do calculation to find out V1, V2 and V3. So at here you can see in this screen as I shown for the calculation V1. So we start beginning from output of A1, which means inverting amplifier. So we do calculation, we get V1 negative 1 volt. Okay, we are using this formula V out equal to negative RF over Rin times with V input. So this the value we get for V1. Alright, we go to next part. For output of A2, inverting amplifier, same formula usually we use as A1. So we do calculation, we get V2 0.4 volt. And last part, output A3, differential amplifier. Okay, this part we using different formula. The formula was V out RF or R in. So at here we need to times and minus V2 minus V1. So at here we get the value V3 equals 40 volt. Alright, I will pass to Kura for the next part. Thank you.
Hello, hi. My name is Kuranamudan. So today I'll be talking about multiple stages operational amplifiers again. So let me share my screen. So this is the circuit I built to see this question that given to me, which is question 6 number 3. And so I've used the basic resistors and basic OMs, which is the code name for the OM is 741 OPAMs. So when we run it, it shows the value of V1 negative 483 and for negative value V2 is negative 19.0 MV and for value V3 is 5.27 volt. So now while the result is not same as what we calculated, but even though this result is not exactly match what we get using manual calculations, they are close enough to make sense and show that the circuit is working as expected. In real situations and even in simulations, small difference like this can happen because of how the simulated models and components are due to small variation in the values. But approximately the values are same as what we calculated. So in conclusion, the circuit effectively demonstrates how carefully designed Here, Jane can take small input signals and amplify or process them meaningfully. It's a great way to explore analog signal behavior. And this approximation reminds us that engineer is as much about understanding practical outcomes as it's about theory. So thank you.